Assalamu alaikum. Here is your chemistry teacher Osama Shahab with you. Hope you all are safe, fine and healthy. Today it's our lecture number 20 and the topic of today's lecture is chromatography technique. Chromatography technique is used to check the purity of any substance. It contains few apparatuses like chamber. This chamber is used for chromatography especially. Then this is chromatography paper. This is the solvent which is used to dissolve the mixture or compound in which we are going to check the purity. This is the bottom line which is used to draw on the paper, and on this line we have to make a dot of the mixture of the compound which is going to be checked. By the use of this bottom line, we are able to calculate the RF value easily. For example, we need to determine the purity of a food coloring. For example, we have a custard powder. In this custard powder, we have to check the dye, that dye is pure or impure, or that dye is made up of single component or more than one component. So what we have to do, we just have to take some custard powder, dissolve in water and then filter it. After filtration, we will get pure dye of custard. Here starch component will be removed by filtration process. Now we are able to check on which components this dye is made up of. So what we have to do, we just have to take a spot of this dye onto the chromatography paper and just dip into the solution. This solution may be of single liquid or it may be of more than one liquid. Like for the custard, we have to use a mixture of ethanol, ethanoic acid and water. The mixture of these three solvents are used for the separation of custard dye. We took a spot of custard dye onto chromatography paper and dipped this paper into the solution and then closed the chamber. After a few minutes, you will find that here we have two spots. That means this dye, this green dye of custard is not pure. It is made up of two different components. The chromatography paper with the separated components is called as chromatogram. Chromatogram shows that the food coloring is a mixture of two dyes. This green color is made up of yellow and blue color. However, if there is only one spot on the chromatography paper, that is showing you that the component is pure. Now, RF value. The positions of the solvent front and spot on a chromatogram depend on how long the experiment was allowed to run. Chromatogram after a period of time, this. Chromatogram after a longer period of time is this. It means whenever you take time, the dye will start moving upward. It will start dissolving into the solution which we use as a solvent and start moving upward. So if it will take a shorter time period, so it will travel lesser, and if it take a longer time period, so it will travel longer. Now what are the RF values? The ratio between the distance traveled by the substance and the distance traveled by the solvent is a constant. For example, RF value is equals to, it is the ratio between distance covered by the substances present in the mixture divided by distance covered by solvent. This is the RF value. For example, we dip this paper into the water and the solvent which is present in the beaker is travel towards upward This is the distance which is traveled by solvent, and this is the distance which is covered by the substance which is present in the mixture. This ratio is called as RF value. Now, for example, chromatogram 3 centimeter is covered by substance and 4.5 centimeter covered by solvent. When we divide it, it will give us the ratio 0.67. And the chromatogram after a longer period. So the distance which is covered by solvent is 5.2 and the distance which is covered by substance in a mixture is 3.5, and the ratio is again 0.65. So either we use a chromatogram after a short period of time and either we use a chromatograph after a longer period of time. It will give us the ratio which is fixed. The RF value of a substance does not change as long as chromatography is carried out under the same conditions. We just don't have to shake the model of the chromatography or the chambers of the chromatography. We just don't have to change the temperature. We just don't have to change the pressure of the atmosphere. We just do the process in the same conditions or in the room temperature pressure conditions. So if we do chromatography in longer period or if we do chromatography in shorter period, it does not matter. It will always give us the RF value which is constant. So this property allow us to easily identify the substance on a chromatogram because the RF values of the compounds are standard. So we just check these RF values with the standard RF values, which will tell us the component which is present in this mixture. How can we identify a banned substance present in food coloring? Chromatography was performed on a sample of food coloring X and 4 band dyes A, B, C and D. If X contain any of these 4 band dyes, it is not safe to be consumed. So what we have to do, we just have to do chromatography and we have to take a solvent in which these substances are soluble. Then we have to do chromatography in the chamber of chromatography and in the fixed conditions. Then we will get some spots. Now we got this after chromatography. Identical dyes produce spots at the same height. Okay, sample X does not contain the band dyes A, B and D. However, X contains the band dye C, therefore it must not be consumed. How can we identify this? Because you can see this, X had the same green color, X had the same red color as C. That means X contain C band dye and X does not contain A, X does not contain B and X does not contain D, because there is no spot on A, B and D as spot on X. So that means A, B and D band dyes are not present in X, but the band dye which is C is present in X, so X is not suitable for the use in the food flavoring agent. What other conclusion can be drawn? Dyes A and D are pure. That means they contain only one component. It means they are pure. Both dye B and C are mixture of two different dyes. You can see in this, B is made up of two components and C is made up of two components. And sample X is a mixture of three different constituents. Okay, so this is the other conclusion which is made by this chromatogram. How do we identify colorless substances? Chromatography can also be used for colorless substances such as amino acids. To separate and analyze colorless substance, we apply locating agent on a chromatogram. What are the uses of chromatography? Chromatography is used to separate the components in a sample. for example, if we have one compound, so we can separate a compound into different components. It is also used to identify the number of components in a sample. For example, if I am using a dye in custard powder and I don't know how many components are present in that dye, so by chromatography it is easy for me to calculate the number of components present in that dye. Okay, so number 3 is it is also used to identify the components present in a sample. It is not only used to tell us the number of components, but it is also used to tell us the exact components that are present in that dye or in that compound. It is also used to determine the purity of a sample. If it contains only one spot, that means it is a pure, but if it contains more than one spots on the chromatogram, that means it is impure or made up of 2 or more components. Okay, so your homework is you have to define the chromatography techniques. Number 2, you have to define the RF value, and number 3, you have to write down the uses of chromatography technique. Thank you so much for your time and attention. If you feel any problem while working your homework, you can ask before 9 o'clock today. Stay safe, stay blessed. Allah Hafiz.